Okay, I'm going to be talking about astounding evidence for Noah's flood. In the culture, we hear statements like this. This is by an anti-creationist, Arthur Strahler. It says, mainstream science has no obligation whatsoever to attempt to refute flood geology, a hypothesis vaguely and confusingly worded, lacking in completeness of statement and nearly devoid of evidence. Notice that, nearly devoid of evidence. A retired Christian professor of geology from Calvin College said this in his book called The Biblical Flood: there is no geological evidence to confirm the idea of a universal deluge. He says there's no evidence. What do you do with statements like that when the Bible is so clear there was a global flood? Well, this is my theme verse for research. It's like the Bereans who test everything. But this is 1 Thessalonians 5:21. Examine everything carefully, hold fast to that which is good. I'm going to hold fast to the Bible as God's word, and Jesus is my Lord and Savior. But then I'm going to examine everything carefully. If you don't examine things in depth, a lot of times you might know enough just to get in trouble. So that can be a big problem. But I try to find out as much observations as I can and then stick to the Bible. And I'm finding all kinds of answers to challenges that they give. Anyway, the Bible strongly indicates it's a global flood, not a local flood. The context was for a global. The ark landed in the mountains and not down in a floodplain. And that's a signature of a global flood. I'm going to skip some of these, but I'm going to talk about like the animals. Why the animals need to go on the ark? Well, they didn't if it was a local flood. Covenant of the rainbow would make no sense if it was local flood. For instance, here's a cartoon from Answers in Genesis. Look at that beautiful rainbow. It's a promise from God that he'll never again flood the entire earth as he did in Noah's day. Well, my Christian professor said that Noah's flood didn't cover the entire earth. He told you it was just a localized flood. That's what he said. So he believes that God promised to never again send a localized flood. See the problem? If you believe in a local flood, it's obvious it's a global flood. Then what did Jesus say about it all? Did he believe it was a local flood? No. In Matthew 24:37-39, it says, but as the days of Noah were, so shall also the coming of the Son of Man be. It's comparing the flood of Noah's day with his second coming. For as in the days that before the flood, they were eating and drinking, marrying and giving in marriage, until the day that Noah entered into the ark, and knew not until the flood came and took them all away, so shall it be with the coming of the Son of Man. Jesus believed Noah was a real person, and the flood came and took them all away. The ark was real. Now, if it's a local flood, he's actually comparing his second coming, which Revelations 1:7 says will be a global coming back. He's not going to compare a global coming back with a local flood, but with a global flood. So Jesus believed in a global flood, and if Jesus believed it, I'm certainly going to believe it. So I'm going to talk about evidences. The first evidence I'm going to talk about is from flood traditions. All over the world, we have flood traditions, global flood traditions, hundreds of them from cultures as diverse as Mesopotamia to the Hawaiian Islands. And when you plot the various elements in it with what happened in the Bible, you can see that there's a lot of similarities. A green square means a full representation. A triangle represents a partial. Partial because sometimes it's difficult to tell what these stories are, because they're always have multiple gods, and they're always the one that was saved, and a lot of things like this. So it's hard to compare them, but you can see that they compare quite well. The closest are those in the Mesopotamia, the Assyro-Babylonian ones, especially the Epic of Gilgamesh. Now, of course, would you have it? Some theologians said, well, maybe the Epic of Gilgamesh is the original, and Noah just, the story of Noah's flood was just copied from that. Well, if you compare how reasonable each account is, you find out that the boat in the Epic of Gilgamesh is 120 feet by 120 feet by 120 feet. It's a cube. How is a cube gonna, it's gonna go round and round. It's gonna be, it won't, in rough seas, it'll be very problematic. Well, the boat in the biblical version has a ratio of 6-to-1, very similar to modern ships and barges today. So that, and this indicates a real event. And as people spread out, it became distorted with time. So I'm going to talk about evidence from strata. They claim that the best evidence for evolution is in the fossils in the strata. And the strata shows slow processes over millions of years. That's the alternative uniformitarian paradigm of secular scientists. Slow, gradual processes that we see going on today, like a flooding river and sending sediment downriver and then laying it on a floodplain or in a delta out in the ocean. But the evidence from strata shows a completely different pattern from uniformitarianism. For instance, from the Bible, we can diagram the flood into various stages and phases. The first 150 days when the water rose, it'd be the flooding stage to when it reached a peak, and then it retreats. This is like any flood, and this is would be compared to a flash flood where it starts off violently with the fountains of the deep and the windows of heaven being unleashed. So it's probably a rapid rise, then a slow rise, phases 1 and 2, until you reach the peak, phase 3. Then during the retreating stage, the water's moving in wide current, maybe 1,000 miles wide and 3 miles deep. If you look down current, you have the consistency of a sheet. So we kind of call it sheet flow, resulting in sheet erosion of the continents. And then it channelizes when more mountains and plateaus are exposed above the floodwaters. It's forced to go around these objects, so it produces channelized features, the channelized flow phase of the flood. And we can see these things on the surface of the earth, phases 4 and 5, which I'll talk a little bit about later. So when we talk about the flooding stage, this was a stage when those sedimentary rocks with their billions of fossils were laid down. And a good place to see sedimentary rocks is in Grand Canyon, where you have about 4,000 to 5,000 feet of horizontal bedded sedimentary rocks. And you notice several things here, is that some of these rock units called formations can be traced over large areas, not little areas like we'd expect in local floods, but huge areas. Like we can trace this formation near the top, the Coconino Sandstone, clear through the canyon, 220 miles through the canyon, and it extends clear eastward into Kansas, but it's given different names in different states. At the bottom, there's a sandstone called the Tepete Sandstone, and that can be traced over half of North America, as I'll show. That's the Tepete Sandstone right there. It's a unique sandstone. It's coarse grain. You can see the pebbles of granite, quartz that are in it. Very typical of sandstones that are on top of the upper crust. The Earth's made up of core, mantle, and crust. This sandstone is generally on the upper crust, and we can trace this up into my area of Montana and Wyoming. It's called the Flathead Sandstone. It's about 100 to 300 feet thick, and we can trace it clear to the Appalachian Mountains. Here is the Flathead Sandstone around Cody, Wyoming. Here's where it is in the United States, and in your country, it extends up into through the Rockies up into the northeast Queen Elizabeth Island. So it covers about half of North America. So I ask you, what kind of present processes are going to lay a fairly even layer of sand 100 to 300 feet thick over half of North America? And this is typical of other formations, not as great as a Tapete sandstone, but it's typical of formations there. You can follow them for 1,000 miles. This is totally against present processes over millions of years, but is what you'd expect in Noah's flood, where it laid deposits over a huge area. Another feature in the Grand Canyon is you find layers one on top of another with little or no erosion between the layers. Now, the secular scientists claim that these horizontal sedimentary rocks represent 250 million years of deposits, various environments, shallow marine environment to a terrestrial environment. And so if that was the case, where's all the erosion? Because erosion in a million-year timescale is rapid. We should see canyons and valleys cut all through these sedimentary rocks and filled in with the next deposition. But we don't. We find these layers one laid right after another as if it was done quickly. This is exactly what we expect in the flood. So getting back to erosion over millions of years, all continents can be eroded to sea level in 10 million years at today's rate. But there's some caveats to that. There's features that'll cause more erosion, features that'll cause less erosion, but still you can put a maximum of about 50 million years to level all the continents to sea level. That shows how fast erosion is on a million-year timescale. So you should see the erosion in the walls of the Grand Canyon, which you don't. So here's a little schematic. Let's say we had a deposition over, say this is a sequence of 1 million years. If it's too long, it'd wipe the whole thing out anyway. So here we have 4 layers laid down. So we have a pause of maybe 100,000 years, and in that pause, it erodes valleys and canyons in those sedimentary rocks. And then you have a flooding situation again that fills in those valleys and deposits more like this. And then it happens again. And so this is what you should see in the walls of Grand Canyon if they're even 1 million years old, just valleys and canyons all over. But this is what you commonly see. The layers with sometimes hardly any change in thickness over 200 miles in the canyon. Sometimes they do change thickness, like in this blue and this reddish layer here. So this is what you see, which defies uniformitarianism or present processes over millions of years. And in fact, this is the southern Teton Mountains of northwest Wyoming. The Teton Mountains are sharp granite peaks in the central part where it rose the most. But the sedimentary rocks that were on top at one time were not eroded off in the northern and southern end. This is the southern Tetons showing the sedimentary rocks layered, just like in Grand Canyon. In fact, this is representative of the bottom 2/3 of the Grand Canyon. And it's about 1,000 kilometers from Grand Canyon. Just like I was saying, the layers deposit over wide areas. But 3 geologists studying this said this about it: the regularity and parallelism of the layers in well-exposed sections that I just showed you suggests that all these rocks were deposited in a single uninterrupted sequence. That's what the conclusion is and should be. But do they believe it? No. However, the fossils and regional distributions of the rock units show that this is not really the case. They're not believing their observations. Observations are the key to science, but they're going back to their hypotheses of deep time stretched out over millions of years. The incomplete nature of the stratigraphic record, that is, those layers, becomes apparent when the spans of time represented by each of the various formations are plotted on a numerical time scale. So they plot it. Here it is. 500, 1 million, 400, 300. And these are the formations in blue. But look at all that empty space in there. A gap of 80 million years here, and probably about 40 here. And by the way, even in these blue areas that look like you got 10 million years of sedimentation, they're full of gaps too. All kinds of gaps, to the point where according to some secular scientists like Andrew Miel, only 1% of the sedimentary record is there. 1%. It's composed mainly of gaps. Then where's the erosion? It's not there. Strong evidence for Noah's flood in the sedimentary rocks that they use to claim that Noah's flood is false, and that we have to explain everything by slow processes of erosion over millions of years, and the proof of evolution supposedly in these sedimentary rocks. So let's talk about fossils, evidence from fossils. How to form a fossil? First of all, you got to bury it rapidly. And it must be fossilized before decay. That is, you got to get inorganic chemicals like silica and calcite jammed into the bones or the shells and turn them to stone before the fossil or the organism decays. Must happen rapidly. So as a result, fossilization is a very rare event. It does happen, but it's rare. And that's why Ken Ham's statement of billions of dead things buried in rock layers laid down by water all over the world as evidence for the flood really says a lot more than when it first appears. Because fossilization's so rare, and the fact that we have billions, probably trillions of fossils in those sedimentary rocks. And a lot of times these fossils are in large, what we call graveyards or bone beds. Here's a graveyard of ammonites, like the coiled nautilus that lives today, all jammed together. We have a lot of dinosaur graveyards too. A lot of them in Alberta and Montana, Wyoming. West of Great Falls, Montana, there's a graveyard of 10,000 duck-billed dinosaurs, all the same species, which is very interesting and unusual if you are thinking of slow processes or natural processes over millions of years. And we have these amazing fossils like fish eating fish, buried and fossilized before it can swallow its dinner. And then we have this amazing fossil of an ichthyosaur giving birth right there. That's not an extra tail, but is buried and fossilized at the point of giving birth. Some amazing fossils indicating rapid burial. And then when you look at mollusks, which are like clams, but there's oysters and brachiopods, other creatures like that, 95% of the fossils are marine mollusks. And most mollusks are closed-shelled. Ocean bottoms and lake bottoms today have very few intact mollusk shells. See, when a mollusk dies, the organic molecules that are holding the shell together break apart and the shell opens in a matter of days to weeks. The fact that we have so many closed-shelled mollusks indicates rapid burial and globally. For instance, here's a sample of fossil mollusks from Washington State, Western Washington, clams, brachiopods, and oysters, all closed-shelled, indicating rapid burial, powerful evidence for Noah's flood. Okay, we're going to shift gears here. We're talking about the sedimentary rocks thickening with their fossils. Now we're going to talk about the runoff of the floodwaters as the continents rose. It's called the evidence from geomorphology. Geomorphology is the study of the shape of the earth, and it focuses on what's called landforms, the form of the land, like a mountain range, a plateau, a mesa, things of this nature, plains. There's a lot of them. So the evidence from geomorphology is tremendous evidence for the runoff of the floodwaters that they have very difficult time explaining. They attempt explanations, but they fall far short. So we've transitioned during the flooding stage. You deposited that sedimentary rock, sediments became sedimentary rocks by cementing. And then as the continents were coming up out of the floodwaters, the water was rushing off at high speeds into the sinking ocean basins. It's called the retreating stage. And at first it's moving as a sheet, large currents, wide currents, 1,000 miles wide, 3 miles deep. And so that's during the retreating stage, the sheet flow phase. It forms certain features as it runs off and erodes the continents. Here's kind of the big picture. This is just a simple block diagram showing that at the peak of the flood, the sediments were probably up about right up in here. There's about 6,000 feet of sedimentary rocks on the continents on the average. So at the peak of the flood, you probably had about 2,000 more feet that were there that are gone. They eroded during the retreating stage of the flood. So you eroded down to the current surface, which is what we see today, and that's where we find a lot of fossils of organisms like dinosaurs. So that's kind of a block diagram or big picture of the retreating stage. So as the water retreats off in wide currents, it forms what's called planation surfaces. You have rough bottom of the floodwaters and it planes these flat. So the definition of an erosion surface, which is similar to a planation surface in the dictionary of geological terms, is a land surface shaped and subdued by the action of erosion, especially by running water. Why running water? Because often they find rounded rocks rounded by the action of water on top of these planation surfaces and erosion surfaces. The term is generally applied to a level or nearly level surface. If it's really flat, it's called a planation surface. If it's sort of rolling, it's called an erosion surface. So a picture's worth 1,000 words. Here's a planation surface in the Bighorn Basin of north central Wyoming. You can see the sedimentary rocks that dip at different angles down to the west in this case. I'm looking south. And something is sheared off those rocks. It's probably a dome, sheared flat. And there's about 15, 25 feet of rounded rocks on top of that planation surface. And it continues over to where I am taking the picture with an intervening valley, because after these planation surfaces form, channelized flood currents commonly dissected them, eroded them, and then post-flood erosion by rivers eroded them. And this planation surface has quartzite, rounded quartzite rocks, which I'll talk about soon. Anyway, when we look at the high plains of Canada and Montana, it consists of a series of planation surfaces at generally 4 altitudes in relation to the Rocky Mountains. The highest level is the Cypress Hills in your country, in southeast Alberta, southwest Saskatchewan. Here they are right here. Notice the scale here, 100 kilometers. So this is about 100 kilometers long and about 15, 20 kilometers wide. And it's been dissected by probably further flood erosion and post-flood erosion. So it's once continuous. It's a high plateau where the western end here sticks up 2,500 feet above the river to the south, the Milk River, and the river to the north, the South Saskatchewan River. So it's a high plateau sloping down to the east, to east end Alberta. I mean Saskatchewan. So here's a picture. The Cypress Hills, Reeser Lake, in the northwest part of Cypress Hills. They shouldn't have called it the Cypress Hills. They should call it the Cypress Planation Surface. But this is a very touristy area, so I don't think that would sell too well to the public. And anyway, it's flat as a pancake up there. And here it is in the central part, Upper Battle Creek, and here it's partly dissected. And I found big erratic boulders from the Ice Age, from the Canadian Shield in here, indicating some post-flood erosion also during the Ice Age, which affected this area. Now the Cypress Hills, the western and central part stuck up above the ice about 300 feet. So the top wasn't glaciated except in the eastern part, which is over here near East End, Saskatchewan. There it is, flat as a pancake. And when you drive up to the top of it, it's like I said, flat as a pancake. It reminded me of driving through Kansas when I was 18 years old. And anyway, when you drive to the edge of this planation surface, oops, got to skip, oops, I guess I don't have those. Anyway, when you drive to the edge, you find out that it's capped by 25 meters of rounded rocks. I'll show them in the quartzite section. But anyway, Lester King, I'm quoting him. He's my favorite geomorphologist from the University of Natal in South Africa. He's a world traveler. He's written all kinds of books about planation surfaces and the geomorphology. He says this is about planation surfaces. They were once much larger. A planation of extraordinary smoothness developed over enormous areas in all the continents. From it, that is these planation surfaces, most of the world's present scenery has subsequently been carved by renewed erosions. Yes, once they're formed, they're broken up or eroded so that you're just left with erosional remnants that you can line up from one area to another and see that they were once connected. They're once much larger. And they're being destroyed today. They're not forming. That's the key to this. They're not forming, so it's not a present process to form planation surfaces, especially when some are 100,000 square miles in area. Here's a planation surface east of the Little Rocky Mountains in north central Montana. It's so flat there that they built an airport on it to the left that you can't see. But it's being dissected by this stream coming out of the Little Rocky Mountains. Present processes are destroying them, not forming them. So if uniformitarianism, that is slow processes of erosion over millions of years, is what has occurred, this is what we'd expect with dipping sedimentary rocks, which are generally alternating hard and soft layers. The hard layers would be left as ridges, the soft layers would erode more, forming valleys, and some of the debris from the erosion ends up in the valley. This is what we should expect everywhere from erosion if it was slow process over millions of years. And we do see this, by the way, in some areas, and this can be explained by slow currents. But I think fast currents created the planation surfaces, because this is what we often find, hard and soft layers sheared off at the same angle and leaving a capping of rounded boulders on top. And some of these planation surfaces are on the tops of mountains, some are plateaus, some are plains, indicating that they're widespread and formed by water, even though they're at high altitudes. Here's a summary of planation surfaces. They're not forming today, but they're being destroyed. That's what we observed. That is the science in all this. They were once much larger, and they're common as erosional remnants. They're worldwide. They're difficult to explain by the slow processes over millions of years model, the uniformitarian model. This is powerful evidence for the global flood, the runoff of the global flood during the sheet flow phase. Another feature that we see on the Earth's surface is quartzite rocks spread hundreds of miles from their source. Quartzite is a metamorphic sandstone. It started off as a sand and was gradually buried, cemented to a sandstone. And then it was buried further and heated up to about 500 degrees centigrade. And sand, being mostly quartz, recrystallized and filled up the pores. See, sandstone is about 25% air in sandstone. But in a quartzite rock, it filled up those pores, becomes hard and dense. It's one of the hardest rocks in the world. And it outcrops in the western Rocky Mountains of the United States. And during the flood, during sheet flow erosion, the Western Rockies were coming up first. And the softer rocks were pulverized by the fast flow. But the quartzites, resistant rocks, were eroded from big sheets. Central Idaho, northern Idaho, western Montana, and spread far to the east into Manitoba, central Saskatchewan, North Dakota, 800 miles from their source. And then when more of the Rockies came up above the floodwaters, it split the current with water flowing towards the Mississippi River Valley, and then another current developing going the opposite direction towards the Pacific Ocean. This is the big picture of the uplift of the Western North America. And so as the Rockies became exposed, the currents were going either way, east and west, spreading quartzites far to the east and far to the west. In fact, there's quartzites I find around the Vancouver, BC area. They're Chilliwack. I wouldn't be surprised if they're a lot more extensive there. I have not looked. I've only looked in one spot. But anyway, here is where they're generally found. And by the way, there's quartzites up in adjacent Canada, generally found in this area. This is where they eroded from. And they're spread from central Idaho, clear to central Saskatchewan, southwest Manitoba. And in the United States, they're spread clear through here into Wyoming, out into eastern Wyoming. And in a few areas like this big green area, which represents a large area or a deposition of quartzite, rounded boulders in a big, deep crack. Right here and right in here. This crack is piled up quartzite rocks, 15,000 feet thick. Here, east of Jackson, Wyoming, and just part of southeast Yellowstone Park, there's a big area of quartzites that are now 11,000 feet thick. And according to the state geologist of Wyoming, 80% of them have been eroded, deposited, then eroded as probably this area came up and spread further east into Wyoming. And right in here is the Teton Mountains. And they were actually spread through this area. The Teton Mountains came up and carried some of them to the tops of the mountains. In fact, here's the 10,000 feet on Red Mountain. We find the quartzite rocks right in here, these rounded rocks. The top of this is the northern Tetons. It's limestone, but so the quartzites stand out like a sore thumb. Some of them have been split, I think, from due to cracks or frost action. The largest quartzite I found is this one right here. Notice how rounded and smooth it is from the action of water on the top of the Teton Mountains. In fact, I have found quartzites on the tops of 4 mountain ranges, and I've been to these places. Teton Mountains, the gravelly range of southwest Montana, the Wallowa Mountains in northeast Oregon, and the Blue Mountains of central Oregon. And here's the, on the top of the Teton Mountains, here's a quartzite. But notice one feature here that is common with rounded quartzites at a lot of these other locations. They have these semicircular cracks on them, right in here. Those are called percussion marks caused by the banging of rock against rock. Percussion marks aren't forming today. In fact, this is powerful evidence of the turbulence during the flood. Powerful turbulence, currents probably going 160 kilometers per hour, 100 miles per hour. So I've been to many of these places, so I plotted them. Here's the Wallowa Mountains right in here with a lot of quartzites on the very tops of the mountains. And here's the Blue Mountains down here. They're all through the lava ridges around the Yakima, Washington area, all through the Columbia Gorge, clear to the Pacific Ocean. And they're found in the Puget Sound areas. I found them at 6 locations, including Whidbey Island and Camino Island. And like I told you, I have found them east of Vancouver, British Columbia. And I wouldn't be surprised if they're right in the city somewhere. So look at some gravel pits. See if you can find quartzites. They're rounded, they're dense, and when you break them open with a rock hammer, they have kind of a vitreous texture to them. And this is the top of the Wallowa Mountains at 8,200 feet. Here's the quartzite location. There was supposed to be one 1 meter in diameter, but we never found that one. It's probably in that snowbank there. But my son dug up one that's maybe 2/3 of a meter. Notice how smooth it is and rounded by the action of water at the top of the Wallowa Mountains. In fact, the Wallowa Mountains had a placer gold mine at the top for a while until it became a wilderness area and had to shut down because the currents were moving so fast during flood runoff that in these finer materials, there's gold. So they placer mine it like you do at a stream. Fantastic evidence for the flood is the runoff, is the spread of these quartzite rocks. And like I said, all these planation surfaces here, these are the top 2 planation surfaces right here and right here, the Flaxville and the Cypress Hills ones. By the way, there's 2 other levels. down below to the point where practically all the plains in here have quartzite rocks on them. So the Cypress Hills, I'll point out, a Planation Surface has about 23 meters of these rocks. Now, buried below the glacial material, the glaciers churned up some of this formation, the Empress Formation in this blue area. A lot of that is quartzites, which I've seen in central Saskatchewan. When you drive to the edge of the Cypress Hills, Planation Surface, you notice what the top is. It's quartzite rocks cemented together to form a conglomerate. And we're looking down 1,000 feet below to the next Planation Surface. When you close up, you can see the rounded rocks all cemented together. It's a great place for people from Vancouver, BC to vacation, and you get a huge understanding of the flood. There it is again. A lot of these quartzite rocks have an iron staining. I found that in numerous areas. It must have been an iron-rich environment when these quartzites were spread during the flood. Here's one from the Cypress Hills, and these percussion marks are quite large. These are the largest I've ever seen. Really dented that quartzite, which is, remember, this is one of the hardest rocks in the world, and look how dented it is. Powerful evidence for the turbulence, fast current of the runoff of the floodwaters as the continents were coming up and the ocean basin sinking, which I could talk more about, but I don't have time. So here's kind of the big picture. The current running off the Rocky Mountains and flattening the Cypress Hills, forming a planation surface. And bigger rocks were slid around along the bottom, smoothing it like sandpaper, smoothing hard, rough wood. But the small to medium-sized rocks were carried up in turbulence and come crashing down, forming the percussion marks. We can estimate the current speed by an estimate of the fall velocity with the largest possible rock carried up into suspension. So based on that, an open flow channel, open flow equations and civil engineering, channel flow, my friend Peter Kleber from Great Falls, Montana, estimated from a 6-inch wide bullet-shaped class to 6 inches wide, that the minimum current speed has to be 65 miles per hour and a minimum depth of 180 feet coming off the Rocky Mountains, planing the Cypress Hills. These are minimums, remember. What are we talking about? Powerful evidence for the runoff of the floodwaters during the retreating stage of the flood. So in summary, quartzite was spread 800 miles east from the source in the Western Rockies, west of the Continental Divide, spread 400 miles west of the ocean, including the Vancouver, British Columbia area. Percussion marks indicate torrential flow, powerful evidence for flood runoff. And this is something that they have extreme difficulty explaining. In fact, I'd say impossible, but I hate to use that word. Anyway, the last feature in geomorphology, by the way, there's a number of features that they can't explain that are readily explained by the runoff of the floodwaters. The last one is called water gaps. A water gap is a gorge through a mountain range or a plateau or a ridge in which the river starts on one side of the mountains and passes through to the other side. They're gorges through mountains. There's thousands of them across the earth. And here's one right here near where I live. This is Cody, Wyoming. Right here, I'm looking west toward Yellowstone Park in the distance. The Shoshone River starts in southeast Yellowstone Park and moves straight east and continues through this ridge of mountains right here called the Rattlesnake Mountains, and passes through a gorge 2,500 feet deep. It started wide and became more narrow. And the river should actually, when the sediments were higher, should have gone on around like this to the south and passed out and like that. That's how the river should have acted. If the river did the erosion, which I don't believe it did, but secular scientists believe that it had to, or it was part of the story. So when we drive through the Shoshone water gaps, it's a granite uplift with sedimentary rocks banked along the granite. And when we drive all the way through, they put a dam right in the water gaps because it was quite narrow. And here's the water gap right here. And this is the dam, Buffalo Bill Reservoir, about 300 feet thick, 300 feet deep, excuse me. And you can see how low the area is to the south where the river should have went around. It's so low that they had to build another dam there so that the water can pour out in the Bighorn Basin and Cody area. But they use that for irrigation to irrigate that that dry Bighorn Basin. And in the Appalachian Mountains of the United States, there's about 1,700 water gaps. Here's the most famous one in the Susquehanna River north of Harrisburg, where you actually have 4 aligned water gaps. This is the last one. I'm looking north, right in here. The rivers should have easily gone around the ridges, but instead they cut through them. You know, unexpected. That's not what you expect by a normal river. And the Zagros Mountains in southwest Iran are really crazy mountains. And a guy did a PhD thesis there, Thomas Oberlander, and he published a book called The Zagros Streams. And he noticed that there's about 300 or more water gaps, some 8,000 feet deep. And this is some of the words he said in his book. The Zagros drainage pattern is distinctive by virtue of its disregard of major geological obstructions. That's the mountains, both on a general scale and in detail. That's a small scale. Certain streams ignore structure completely. Some appear to seek obstacles to transect. Can you imagine that? Some of the rivers go through a mountain range, then come back out. Some of them go partway in, then come back out and do it again. So it's crazy. They don't normally flow down valleys like they're supposed to. That's why this is, I laughed my way through this because it's so crazy and they can't explain it, even though they attempt to. And we actually have an analog of the formation of water gaps as well as wind gaps in the Lake Missoula flood. Western Montana valleys during the Ice Age filled up with water 2,000 feet deep, about 540 cubic miles of water, and it broke and moved through eastern Washington, carving it up into what's called coulees, vertical walled valleys, flat bottom valleys, and did it quickly. And in the southern part of Washington, it crossed a 500-foot ridge, and it formed Palouse Canyon. Started out about 8 miles wide and become very narrow with time, sort of like the Grand Canyon. And the Palouse River used to flow down Washtuckna Coulee to the Columbia River. But after the flood, it took a left-hand turn and passed through the water gap formed during the Lake Missoula flood into the Snake River. Over here to the west is Devil's Coulee, a wind gap. It's blocked here to the north, and so water can't pass through, but only wind, so it's called a wind gap. And here's the big picture for the formation of wind and water gaps. There's thousands of these across the earth. You had the floodwaters draining, and you had mountains and ridges coming up, happening together. Sheet flow, and it was going across the ridge. Ridges aren't perfectly flat, so it takes advantages of low areas and digs them out. And as part of the ridge is exposed, it forces the water to flow rapidly through these gaps, eroding rapidly, forming a water gap and wind gaps. As it continued, this one gave up for some reason due to tectonics or different shifts in the water currents, and all the flow ended up going through here, forming a water gap to the point where the rivers at the end took advantage and passed through the mountains in the water gap, leaving what could have been a water gap high and dry as a wind gap. So that's how you explain the origin of water and wind gaps, which secular scientists have extreme difficulty explaining. We can easily explain it during the runoff of the floodwaters. So why can't mainstream geologists see the evidence for the flood? It's all over the place. I'm saying it's abundant. And I only showed you several features in geomorphology. There's probably about a dozen features that I can show you. Well, you know, it's a psychological phenomenon that's been discovered by several scientists. I ran into it by accident in a book called The Promise of Sleep by William Dement, professor at Stanford, who was one of the discoverers of REM sleep. He says on page 34, even when they are looking, people usually see only what they expect to find, and they do not see what they assume for whatever reason could not exist. So Davis Young, in that quote I gave earlier, doesn't think there's any evidence for the geological flood. It's because he's looking at the world with uniformitarian glasses on. And he doesn't expect to see big formations with little or no erosion between them. Planation surfaces, quartzite spread 800 miles, and water gaps form because he's not expecting them. And guess what? He doesn't see them. That's why he can say there's no evidence, while there is abundant evidence. So, if you want to know more about this issue, this is part of the creation evolution issue. If you have a lot of questions on this issue, I suggest getting the Creation Answers book. We get the same questions often in audiences, and Creation Ministries International compiled them into about 60 questions and answers. What about carbon-14? What about dinosaurs? Where did Cain get their wife? I mean, common questions, and give you answers. So if you have questions in this area, this book has answers, and they're written for a layman. And this talk is summarized in this book, How Noah's Flood Shaped Our Earth. And it's chronological, starts off with what we know about the before the flood. We have clues from the fossils and the rocks in the Bible. And the details of the flood, starting with the flooding stage and going to the retreating stage. And then afterwards, the ice age, which I'll talk about tomorrow at 1 p.m. your time. It'll be about the ice age, and the woolly mammoths follow that. And this focuses on just the runoff of the floodwaters. Receding water shapes the Earth's surface, flood by design. And if you don't know much about geology, I've written a children's to adult book, Exploring Geology with Mr. Hibb. This is a fun read, teaching about geology with cartoons and an intelligent grasshopper. And a new book just came out this year on the millions of years, the deep time deception, examining the case for millions of years. If you have questions about the age of the Earth, when did the dinosaurs die, things like this, and the young Earth timescale, what about all that? In fact, this is one of the most challenging questions of all in the creation evolution issue, the issue of deep time. Anyway, this book gives you plenty of answers. I want to leave you with this verse here, 1 Corinthians 2:5. Your faith should not rest on the wisdom of men, but on the power of God. Evolution, uniformitarianism, deep time are from the wisdom of man without God. We should depend on the Bible that shows us the power of God. And here's a few websites that you can write down for your information. I recommend especially the first one, creation.com, from Creation Ministries International, that has 12,000 articles for all ages, all scientific abilities, from professors to kindergarten children. It has that many articles. You have to use a search engine. You'll get all kinds of articles to read if you have questions. And if your friends or neighbors ask you questions you can't answer, go to the websites. Anyway, I thank you, and I'm open for questions and answers.
Thank you, Mike. Great talk. Really appreciate all the years you've spent studying this stuff, pouring, looks like a lot of hours with just considering all the 100 or more articles, your many books. You keep writing books, like you mentioned, one that just came out. being on the board on the Creation Research Society, I think gives a good insight into what other Christian scientists, those in Creation Circle, are studying and proposing to answers. Keep just plugging away at those some unanswered questions. So if you have any questions, feel free, use the Q&A if you're on Zoom, or use the Facebook comment. We'll have some people helping us to answer some questions. And if nobody has a question yet, one thing maybe I myself have a question. You hear people, secular geologists, use the rock, the chemistry in the rock to date the rock. How about for the rocks that contain the fossils, which are the sedimentary rocks? Do those rocks contain radioisotopes, or can you only get the radioisotopes from rocks that formed during volcanic eruptions from lava that came down from the mantle of the earth, the below surface? Sorry, do they use the sedimentary rocks to try to assign ages?
The radiometric dating methods apply mainly to igneous rocks, your lava flows, your granites, and some metamorphic rocks. And they've tried to date sediments over the years, and they've mostly failed, but there's a few that I've been seeing in the literature. They're always developing these methods, and there's probably about a good 50 of them now. Some more popular than others rather obscure. So in some cases, they can date the sedimentary rocks. Now, if there's a ash layer in the sedimentary rocks, that's an igneous igneous, so they can date that. And if it's in the sediments, then it tells you what the general age of the sediments and the fossils in the sediments are. So they've done that. And all these dating methods are based on assumptions, three main assumptions. The rate of change has to be the constant over millions and billions of years, which I believe is violated a lot because of the creation and the flood. They also have to believe that the rock, once it's cooled, you date the cooling time, once it cools, that no chemicals or elements go in or out for millions and billions of years. And we know that many of these elements that they measure, like uranium, lead, rubidium, strontium, move. And the potassium argon method, the argon's a gas. So we know that things move in those rocks. So that's kind of a questionable assumption. Also, at the beginning, when the rock cools, you have to know the initial elements at that time, millions of years ago. And a lot of times they don't know. And so they have to guesstimate them. Guesstimate them is a term I used in my weather forecasting for making weather forecasts. And that's kind of what they do. They kind of wing their way through a lot of these.
Yeah, so there's I'm sure a whole nother talk or even multiple talks that could be used.
Multiple talks. I have 3 talks just on this subject.
Right, thank you. Yeah, so it's amazing to see all these round rocks, huge boulders on the top of mountains. Like, so I think a lot of people here in BC go out hiking, especially around the lower mainland. You talk about out east as well in BC. So you could be on the lookout for all these features that I think it opens up your eyes to see this catastrophic events that we haven't anything close to that happening these days. So question here related to a round rock. Someone from Facebook asked, how can you tell it's not some kind of fossil?
Well, a lot of times you crack these open and, you know, it's in fact, looking at the surface, sometimes the surface is weathered. And so you have to crack them open. When you do, you see what the real texture is, and you know, they're rocks. I suppose sometimes you can find a fossil, but there aren't too many fossils that are round, which are mainly the rocks I'm interested in, the round ones, because they're formed by water action. So that's why I focus in on the rounded rocks and the hard rocks like quartzites in our area here of the Northwest states and adjacent Canada.
Great. So hopefully that answers questions, but tricky to answer. Just want to mention, probably it's difficult to let the people in person at the Olivet Church there know. There's a mic set up for you to go up and ask your question, and then you can, I think there's a David Lashley there, let him know, he can alert us and get you in line for your question. So make sure that people in person also get a chance to ask. Next question here, can Mike talk about the separation of the continents? That, I don't know if I should limit you to 5 minutes. Yeah, I don't know.
That's a long subject.
Yeah.
So I'll try to boil it down to a minute or so. In flood geology, there's a number of us that work in this area, and John Baumgartner has developed a model called catastrophic plate tectonics, where he believes that there was at the beginning of the flood, there was one supercontinent and it broke up and spread fast. And he has some evidence for this, but I think there's evidence against it. And since I've been a researcher for 45 years now, and I read the geological journals, I try to keep up with about 50 geological or science journals, I find a lot of questions, a lot of problems with this. So using weather jargon, I was a weather forecaster for 30 years. I go along with catastrophic plate tectonics 20%, but it has so many anomalies that are not addressed that I'm against it 80%. So that's my position. But you talk to some other flood geologists, they're probably 100% in favor of it. So it's one of those issues we're divided on. But that's good, you know, because when there's a lot of unknowns in earth science, like there still is, I mean, otherwise, why would there be 50 earth science journals publishing research? It's good to have a lot of ideas. It's called the principle of multiple working hypotheses. Different ideas, and with time you refine these, and hopefully one will shine after a while. Maybe I'll believe in catastrophic plate tectonics down the road, but I'm still researching it. I'm actively doing this all the time, looking at various aspects. It's a big area. Covers huge area: geochemistry, geophysics, fossils, paleontology. Oh man.
Yeah, biogeography.
Biogeography, yeah.
So yeah, I think for people out there, I think we take the stand. We know for sure God's words written, what happens, what it describes happened, which is the global flood. We can try to garner some inferences about durations of when the water's lifted. We know some sources of the water, like from the deep, so kind of like the crust of the earth opening up, the rains. But yeah, we have to try to explain how we get to the present involves a number of assumptions and working hypotheses, like Mike mentioned. So it's good to have this healthy dialogue. So if people are interested, I think there was a forum where two major sides could present their understandings of how the continents got to be where they are today. And you can go creation.com, and I think it's probably search like catastrophic or plate tectonics forum or something. There's technical journal articles for those really interested.
Yeah, 2002, I had a forum with John Baumgartner over it. So yeah,
back and forth.
Yep, back and forth.
So yeah, it's never ending, I guess. Always new insights that come up, and it's good to hear you're into also looking at what the secular geologists are saying. A question related to that: how would secular geomorphologists explain planation surfaces?
Okay. They really don't have a good explanation, and when they have one, it usually applies to a small area. Like there's one hypothesis out that's not believed by many, that it's done by ice, it planed by frost action. I can't remember exactly how it goes. And it's admitted that water does the planing because we find the rounded rocks on them. So a lot of them admit that it's water, but they don't really understand how it can do, especially when they're huge. I mean, they might be dissected, but when you fill in the material between them, and and see how what they once were. They're huge size. Like, for instance, Africa is 60% of Africa is one huge planation surface that has been folded up to and folded to different altitudes. In Australia, the tablelands of Eastern Australia is one erosion surface. It has it's more rolling, and a lot of the central and western part of Australia are planation surfaces. So they know water did it, but I really haven't seen a decent hypothesis from them at all on these things.
Yeah, the scale is just enormous. Think of like almost continent wide, like, and all the continents, right? Like, it's just mind boggling.
Yes, it's more localized in North America and Europe,
Okay.
but they're extensive in Africa and Australia.
Mm-hmm.
You don't have a lot of them in your area. You have to go into the Rocky Mountains and then east of the Continental Divide, then you see lots of them.
Great. So another question from Facebook. Why would there be such a large deposit of petrified wood, fossil, I guess mosses probably, jasper, quartz in South Manitoba, Canada, I believe? Like, I guess also related to that, like the vast amounts of, I guess, oil, petroleum reserves that we find. Yeah, why such large amounts petrified organic material, really?
Okay, I'm not quite sure what the question is. They're talking about petrified wood, or are they talking about oil, or both?
Yeah, well, I guess mine I kind of added on. It's a bit different. So I guess there's a specific region. It's, I believe, type a bit of a mistype, but southern Manitoba, Canada, petrified wood. I think they mean mosses, jasper, quartz.
Okay, I'm unfamiliar with that, but I know that petrified wood is almost everywhere.
Mm-hmm.
In fact, I've studied the so-called petrified forest in Yellowstone Park, where you have layers of vertical trees up on a cliff. Specimen Ridge, for instance, in Yellowstone National Park, places like this. We can explain these and other vertical trees and petrified trees by the log mat model, where during the flood, it ripped up the vegetation, which is from the amount of coal about 10 times as much as we have on today's Earth. And so much of this would be floating over the floodwaters, and it'd be sinking, like at Spirit Lake, Washington. Sometimes the logs would come down vertically and end up in different layers as you form sediments on the bottom. So, and then there's petrified wood in a lot of different areas. It's very common. In fact, it had to happen quickly because some of the rounded quartzite rocks on the Cypress Hills, on the top of the Cypress Hills, I have actually found petrified wood that's been formed by water. So it must have been petrified quickly somewhere else, and then eroded and moved with the quartzites. I don't know if that answers the question, but I'm unfamiliar with.
So there's correct
Manitoba.
spelling, Souris, Souris. Yeah, I guess you might not be familiar in particular.
That's the name of a channel, I think, out that way. But other than that, I'm unfamiliar with that.
Yeah, hopefully, yeah, you could always pass along questions to us. We could probably pass along to Mike and see if he can get some more answers. What about when a person who believes in evolution asks you where all the water of the flood went, where did all the water of the flood go? Where did it drain to? How would you answer that?
Just have to look at half the globe. The Pacific Ocean it covers about half the globe. It ended up in the ocean. See, as the continents rose up, ocean basins sank. See, I get into this in my books more, but I didn't, and I could in some geomorphology talks. But we have evidence of the ocean basin sinking by especially what's called flat top seamounts called guyotes that were flattened near the surface of the floodwaters and are now an average of about 5,000 feet below the surface, so indicating the ocean basins have sunk. And there's other indications, and the continents have risen. So that's a tremendous amount of potential energy when you force water up and then sink it next to it. The water is going to come rushing off at high speeds, eroding and forming these unique features on the surface that we study in geomorphology.
I guess you would have started out during the flood. It would have been the land mass would have been more flat, so then that water could easily distribute everywhere around to cover.
Yeah, I think at the peak of the flood, we had probably in my area of southwest Montana and Wyoming, you probably had about 3 to 4 miles of sedimentary rocks on top of the upper crust that was flat. And part of it rose up high and parts sunk. Psalm 104:8, the valleys rose and the mountains rose, the valleys sank down. And that drained the floodwaters and also filled up those valleys and cracked with sedimentary rocks. So we had a lot of what's called vertical tectonics, which is what another aspect of geomorphology I didn't touch on in this talk, but do in other talks and books. So it started off probably flat on the top, and then due to all this vertical change, it's become mountainous in a lot of areas.
Right. Here's a good question. How were the thousands of plant species preserved during the flood?
I think they probably were preserved, or very likely, in the log mats. By log, I mean logs and vegetation, and sometimes vertical trees floating above the floodwaters, probably still with some green leaves on them, and seeds and all kinds of debris in it. And as the floodwaters drained, it let this material down onto the surface and germinate in the mud at the top of the continents after the water had left. And as far as the salt water, if there's salt water, it'd be raining and it would quickly change to fresh water. So there's all kinds of models and ideas out that it should be no trouble preserving plants and seeds that survived the flood after. A lot of them didn't survive the flood, and a lot went extinct. So it's a combination. A lot went extinct, some survived and are present in today's world.
Yeah, I think a lot of people probably don't realize a lot did go extinct as well. I think there's types of trees called lycopods that kind of formed, like on floating type trees. Yeah, odd. You find
lycopods form a lot of what's called the carboniferous coals.
Here's another question. To what extent would our mountain ranges in BC on the farther west, it's called the Coast Mountains, farther east border in Alberta is the Rockies. To what extent would our mountain ranges have been formed by receding floodwaters versus erosive glacier action during the Ice Age?
Oh, well, as the mountains rose and the valley sank down, they formed the Rocky Mountains and then the coastal mountains, and they formed valleys and glaciation afterwards modified these, but not a whole lot. Just maybe widened some valleys, made them more U-shaped. So there wasn't a lot of erosion during the Ice Age. So what you generally see on the surface was formed during the flood, mainly during the runoff of the floodwaters and all kinds of tectonics occurring, and just lightly touched by glaciation afterwards.
Here's a question. We'll need a bit of background. Are you willing to dialogue with Dr. Walter Brown about this? I guess they mean the certain evidence is presented here, comparing models. So a bit of background. I guess Dr. Walter Brown has what he calls hydroplane model. I guess talking about how the content like floated, I guess, or like hydroplane. Yeah, maybe you have a better way to.
Hydroplate. He calls it. Where the mid-Atlantic ridge rose up something like 16 kilometers, and this granite crust slid off and then come to a halt in mainly Western North America. I'm not willing to dialogue with him, and I'll tell you why. I've dialogued with him before, and I've gotten nowhere. In fact, I was out in the field with him for 5 whole days, examining the question of the origin of the Grand Canyon, which he thinks is from a dam breach. Why I believe it's a water gap formed by channelized flow late in the ice age as the waters were draining. And so he is so set in his beliefs that he is not open to seeing anything else. And so it's just a fruitless endeavor. And some of his friends have asked me to do that. But what I'll do is I'll analyze this model. And I wrote a long critique of it that's on the creation.com website, I think in 2013. Just Google his name or my name and the hydroplate model, and you'll see what I wrote. But I found out when I was out in the field with him that he knows hardly anything about geology. It's greatly surprised me. He's an engineer. And so he made tremendous blunders out there. It just made me speechless. So sorry about that. I'd like to dialogue with people, but I'd like to dialogue with people that are willing to give and take. But he kind of takes over and hardly lets you get a word in edgewise, and is very sensitive. Very sensitive.
Yeah, I guess that's why there's like iron sharpens iron. It's good to put your models forth. There's creation scientists who have journals because, of course, you're not going to get published by secondary geologists who have their set mind. So there can be dialogue there. So I think that's a good thing.
Well, we have some dialogue, and we analyze each other's models and publish on them. I publish freely on catastrophic plate tectonics and the hydroplate model, and the one I believe is meteorite impacts followed by differential vertical tectonics. That's the one I favor, but it has problems. All these models have problems, and we should be open-minded to refine them, change them, or reject them. And like I said, I might believe in catastrophic plate tectonics one of these days. It's got some good features to it.
Yeah, just like you mentioned, when it comes to historical science, like a lot of our conclusions depend so heavily on our starting assumptions. Nobody was there, no scientists, so very hard to arrive at, how we get to the present without knowing those initial conditions. Here's a question: how were the arches in Utah formed? It's amazing, 2,000 of them. It's like a wind, water.
I wrote an article on that in creation.com. I believe they're leftover remnants from the flood. And because what we observe, like in Arches National Park, is that they're being destroyed right now. I mean, natural processes are destroying. They're not forming, well, except in maybe a local area, but it's usually small scale with soft rocks. But those hard rocks, I just think they're due to the erosional processes during the flood. Now, I don't know anything more than that, but it seems like a decent model to account for some of these, like landscape arches. This is a thin one like that. I mean, you got to erode all that material around it, carve it, and just leave something hanging like that. It's just amazing. But I can't see present processes doing it, because what we observe on present processes is that arches are being destroyed today.
Yep. People better think twice about trying to walk across one or something like that.
Yeah, I would. But you can find more information on the creation.com website.
Mm-hmm. So here's a question: if you know about the Joshua Tree, the rock forms in Joshua Tree near Palm Springs, I guess that's Arizona, what are those the result of?
Joshua trees?
No, the rock forms in Joshua Tree near Palm Springs.
Well, there's Joshua Tree National Monument in the Mojave Desert of California. I'm not familiar with what he's referring to.
Yeah, I don't know if that came from the audience there at the church. We can, if someone who wants to clarify that, or I guess maybe submit that question separately. I mean, I guess if Mike's not aware of it. Uh, Here's a good question. Some of the creationists believe that the age of the Earth is 6,000 years, and some of those who hold to long age, others believe it to be billions of years. How would you answer that?
Well, I personally go with what the Bible says. You add up those genealogies from Adam to Abraham, Abraham to Jesus, and it adds up to 6,000 years is when Adam lived. And Jesus said that in Mark 10:6, I believe, that when he's defending marriage, that Adam and Eve lived at the beginning of creation. And there's other places he said that Adam was at the beginning of creation, or people lived at the beginning of creation. So I believe the Bible, and like I said, 1 Thessalonians 5:21, examine everything carefully, hold fast that which is good. I'm holding fast to the Bible. Now, there are Christians that believe in millions and billions of years, and I think it's because they simply believe that those dating methods are so accurate that they can't be wrong. And they can be. And there's lots of problems. I've even written a book about it, The Deep Time Deception, and examining the case for millions of years. I'm not wild about that title. The original title was Examining the Case for Millions of Years, but CMI didn't like it. It was too dull, I guess. So they had to pizzazz it up and made it The Deep Time Deception, which is, anyway, that's where I examine it. But I refer to these things in some of my writings, and I point out a lot of dating methods where they get the wrong date, things like this. They're smattered throughout my works. But I would say that this Christian who believes in millions and billions of years, should examine the issue carefully and a lot deeper.
Yeah, I'd like to add, it probably has some implications to the good news, the gospel, because if you allow for billions of years, you're forced to place death, suffering, pain, disease before Adam was created. And God said at the end of the sixth day, it was all created very good. Yes. So what's the point of Jesus dying for sins? And why did he have to die physically? Is he going to die, resurrect physically? Is the new heaven and earth going to be restored to the same processes of animals eating each other up, like with tumors? And so there's some serious implications also, I would say. So it'd be good to look into those as well. And of course, we follow what Jesus says. Some may say, oh, that's the institution of marriage. But you look at the mark, it's really from the time that God created, not the creation of the institution of marriage. So a question here, if you don't, or let's go back. Someone did say, yes, it is in California, those rock formations in Joshua Tree near, what was the question exactly here? Put it away. Yeah, if you know what those rock forms in Joshua Tree in California would be the result of.
Yeah, I don't know what he's referring to. He mentioned Palm Springs. That is just a little east of Los Angeles. I've never been to Palm Springs, so I have no idea what he's referring to, and what rock formations he's referring to. You'd have to clarify.
Some more detail on that. So question here, someone who's not familiar with your view on the meteor impacts and vertical differential movements of the plates. So if you don't favor catastrophic plate tectonics and the associated magnetic field changes during the flood, how do you explain the magnetic striping of the sea floor?
I believe in reversals. There was reversals in the magnetic field, but when you look at the stripes on the ocean floor, when you look at those a little closer, first of all, what you read about them, they claim that there is normal and reversed rock on the ocean bottom. They form these stripe patterns formed by reversals and normals in the magnetic field during the flood as a continent spread. That's what they say. But when you look at them, they're not actually reversals or normals. What they are is 1% or less changes in magnetic intensity, not direction, intensity. And therefore, you can explain it by differential vertical tectonics by forming linear cracks. And then the linear cracks cause the mantle to rise, and the water reacting with the mantle forms what's called serpentinite, which is highly magnetic. And so you can get differences in magnetic intensity by just cracking open the ocean in various locations as the mid-ocean ridges came up and the abyssal plains went down. So that's a possibility. That's just a hypothesis I have. I have to work on it more. But anyway,
yeah, but I think
what I found when I looked at it closer.
I think one thing we could all agree on, I think it requires rapid processes to kind of lock those features in the rock. And otherwise, like if it's happening in slow plate tectonic movements, you're not going to get that feature in these rocks. It's going to blend out, is my understanding. If you, I don't know if that's correct.
If you want to know more about the reversals and all that, Russell Humphreys has done the theoretical work on that. And he explains it by, I think, catastrophic plate tectonics, but there might be other ways where you change the flow in the liquid outer core. And but that's speculation on my part, but he has a reasonable ideas on how it would occur rapidly during the flood. So Russell Humphreys, you can look on creation.com and get a good smattering of information on his ideas.
All right, so probably the last one for tonight, and then try to wrap up. When God created the earth in the beginning, and there was water everywhere, and then he made the dry land appear. I picture that to look like land coming up and the water running off, as in collecting in its place. Is there anything on the earth or land that still exists to see from that time? I guess maybe the Precambrian, or is there any evidence of that maybe runoff, or I guess that's what they're trying to get at, may have happened during the dry
day 3 geological activity. We're divided on that issue, and I'll tell you the Bible doesn't say, because it says the dry land appeared in the waters below, and so we don't necessarily will have any geological activity, and it could have been just a pure miracle, super miracle, like the 6 days of creation are, and that's what I lean towards. And even if there were sedimentation from erosion from the runoff of the water on day 3, the flood would destroy all that, and you wouldn't find anything. Now the Precambrian is sedimentary rocks, likely are from the flood and not from day 3 activity. And you can, if you read that book, How Noah's Flood Shaped Our Earth, you'll see where I develop the case for that.
Great. So I've come up to 8:30 our time, and want to thank Mike Oard for a wonderful night. I just want to, in closing, thank everybody for coming. I want to share just our website here locally, creationbc.org, the Creation Science Association of BC. So you can visit us at creationbc.org. I want to highlight also, that we have upcoming events. So tomorrow, starting at 1 p.m. Sunday, the Ice Age, only the Bible can explain it. So tied to today's talk as well, coming out of the flood. Actually, Mike will talk about when it happened, why there's evidence for it. Mm-hmm. And then right after that, related to the Ice Age, whatever happened to the woolly mammoths, because I think there's pretty big mystery. Like people will say, oh, they were quick frozen, but is that really possible? And then just want to highlight, we've created a store for our resources. So you don't just need a catalog or call it in or visit our store in person. You can now make your orders for materials through our store. So we have our online store up and running as of today, actually. So thanks to all the fellow directors from our CSABC, Haslin and Daniel in the background working on that. So I just typed in, Mike shared some of his resources, his books. So if you just put in Oard, instead of maybe Mike or Michael, or it'll show up. So he did talk about Noah's flood and the flood by design. He's got a number that will be related to tomorrow's talk about the Ice Age, woolly mammoths. As he mentioned, I would highly recommend this Explorer in Geology with comics and really understandable and even probably suitable for even up to adults, those who don't have an understanding of geology, but also there's just other books for kids like Life in the Great Ice Age, a number of other books that Mike has co-authored, even some very technical details like the cores, dating of ice cores, Greenland, I believe, and Antarctica. So yeah, I encourage you to check out our website, come back tomorrow. And yeah, I just want to thank everybody again tonight. I don't know if there's any other comments or anything else anybody would like to say. Just welcome back.
Save them for tomorrow.
Yeah, maybe if you're thinking of any questions that have come up, come tomorrow prepared. And yeah, it'll be good to see you come out again. Thank you to everybody.
Okay, good night.
Have a good night.